That was a really good bottle of whiskey. All right, so let's get started. So I want to talk about a bit of a different perspective on AI. As AI not as a technology or but really about what we're really after, which is to make business processes work better. These are also some are not in academia or in fundamental research. But for those of us in the commercial world, the purpose is to make the business processes work better. And really, you should think about a science and an engineering of business processes, and AI happens to be a tool that applies quite well to that. So I'll give just a brief background on my journey here. I started as an academic in the 1990s. Then later in the 90s, I became an entrepreneur. We started a couple of companies. Then I spent over a decade in IBM research in Silicon Valley, California, kind of plumbing the depths of applying different kinds of mathematical techniques to business problems. I then became the chief data science officer for GE. And then I founded a startup after that called Noodle.ai, based jointly in San Francisco and Bangalore. And then about 5 years ago, I moved to Miami to take up this role at World Cripping Group, where I'm the senior vice president of data analytics and AI department. So 3 topics I want to cover here today. One is I'll briefly kind of talk about AI and cruise, the kind of stuff that we do in the cruise industry. Then I want to go into the state of AI today as applied to traditional enterprises, and we'll get into what we mean by that. And then talk about how to get it right, which is that scientific approach. So first of all, in the cruise business, we kind of look at the life cycle of our interacting with our guests in terms of these buckets you see here. It starts with planning and picking an itinerary, arriving at the port and getting on the ship. Then there's the cruise itself, which of course is the main thing. That's the product and service that we sell. Then there's getting off the ship, getting home, and then that ongoing relationship. And the ongoing relationship is very important because a loyal cruiser cruises maybe once every 14 or 15 months. So you don't, it's not like they're using your product all the time. And that's a very loyal cruiser. So remaining engaged with them in between cruises is very important. So some of the kinds of things that we do, just to give examples, are shown here. On the top, there's a thing we came up with called Car to Bar in 10 minutes. Which is one of the, people don't feel they're starting their vacation until they're sitting in their shorts at the bar on the ship. And so we wanted to make that period of time from getting to your car in the parking lot, you see sitting at the bar as short as possible. And that's it. So there's rapid boarding, there's face recognition, so just walk through and that kind of stuff. And then AI to match music to cruising. So how do you let people think about what they want to match the best thing to them? So we do itinerary recommendations, activity and show excursion recommendations, things like that. AI for depersonalization, so reaching out to guests, giving better customer service, automated through bots and stuff like that. But then the real money comes from the things you see below that, where we focus on pricing automation and optimization. And that's for the cabin, your room on the ship, as well as all the other ancillary things that you might purchase, inventory management, personalized offers, energy, and so that's the kind of multi-level AI optimization is what we call that. And then there's sort of the hardcore industry 4.0, which is the IoT kind of stuff. And there's energy and fuel minimization. Energy is the biggest cost for the cruise business and for many businesses. And of course, decarbonization is critical, not just for social reasons, but there's regulations about the carbon intensity that you can have in any kind of cruise, and you have to comply with that. So it's a very important commercial thing. Things like predictive maintenance, and machine optimization, and supply chain and logistics. So those are the ones that generate the measurable money. The other things tend to measure more about customer satisfaction. As far as our organizational model, this is the last thing on kind of what we do. We're structured as this data analytics and AI department or function. And the way we structured it, this department has the data warehouses, it has all the platform that sits on top of those to build applications and so forth. It's all cloud-based. It has the BI infrastructure for the company, and then it has a data science or AI solutions team that actually builds all these great solutions. And I see David Whitney's in the audience there. He's the leader of that team, and the things you saw there are the things that his team developed. See Mark there as well, who's our marine expert. I'll be more explicit about that later. All right, so what's happening with AI? with so much that people are saying we can't handle the electricity requirements. The grid needs to be adapted to handle the extra electricity being into this. So you've also got consultants, lots and lots of consultants going around trying to make people feel better about not being behind. So how you can be at least as good as your competitors as far as Gen AI is kind of a big thing happening there. And this is, as we all know, I think even at this event, there's so much discussion of generative AI. I think one of the fallouts from that is that a lot of people seem to be taking their eye off the ball in terms of their AI can really deliver measurable business value. And that's what it's all about. When there's buzz about something like that, you'll get some funding because there's interest. But if you don't show serious commercial return, in a year or two, that'll all dry up. Show for it. So the key questions to ask, first of all, it's not where do I apply Gen AI in my business. The key question to ask is how can AI make my business process work better? Then you have to ask, do I have to build it or can I buy it? Or buy something like it and adapt it? And if I do decide to build it, look down. So I'm talking here about traditional enterprises. And what I mean by that is not companies that were sort of born on data or born on the web, companies like Netflix and Amazon and so forth that were born and the data was this huge thing over. It's companies that grew up and thrived in a pre-datified world. So they were being very successful when data was not a big thing. And because of that, as data started to become a big thing, they adapted datafication heterogeneously, meaning in pockets, silos in the company without applying best practices. So there's a person, there's one function who's kind of good with computers and started using data in a certain way, and another person did it differently somewhere else. And so you grew up these sort of separated silos that don't work very well together now. And that's not a small niche of companies. From the latest time I tried to go and count these companies, it's about 90% of big companies. So it's most companies. That's where AI can actually have the most impact commercially. So from a traditional enterprise perspective, Gen AI is very relevant, of course, and it promises a lot of improvements in things like the very natural kind of killer apps are customer service, contact center applications, conversational AI, automatic code generation, obviously, and things related to that, story generation, project management, and so on, better natural language, and more interactive search, and then of course just general productivity. Whoever writes or creates images or sounds or anything as part of their job can use this in a very productive way. And a proper Gen AI strategy is deciding where to buy versus build these things. These are kind of common things, like even though every company is unique, the core of it is pretty similar across companies. So I would argue buying it from a vendor is probably going to be a better long-term solution for you than adapting it as needed. But again, the important point I want to make is the lion's share of the impact is going to come actually from traditional AI, and the lion's share of the deployment of this is going to come from vendors. So aside from these productivity improvements, this is the point I want to make, which some people may not agree with, but I think generative AI is largely, to me, looks like a technology looking for a place to apply it. It's not like, it's like, how can I apply to Gen AI? Company leaders will see all this stuff in the newspapers and say, hey, are we going to fall behind or are we applying Gen AI? Right? So that's an issue. I think traditional enterprise AI, which is the application of whatever works to make business processes work better, is really about the science and engineering of business processes. And that produces bottom line impact, a lot more revenue. The reason, of course, is because you start with the bottom line impact. How do we have a bottom line impact, and then what can we do to deal with that? So enterprise AI, everyone knows, is very challenging. I think it's pretty commonly known that most enterprise AI projects fail. This is one number from a Gartner Group study where 85% of them failed to get deployed or didn't deliver anything like was promised. And I think you can measure different numbers, but most of them fail. And even if sometimes they're a little successful at first, then they sit kind of stagnant and things change over time and people lose faith in them and they get nothing to use. So over 25 years or so, distilled, I think, are the 6 key secrets for enterprise AI success. And they look pretty simple and non-controversial, but I would argue if people really, really follow these in their hearts and minds, you would see much, much, much higher success rate. The first one, kind of as I've been alluding to, is to focus on the highest leverage business process to follow one. And so that means when we look at projects people actually pick, it's often picked because they had a willing partner in the business. Well, this person was willing to work with me. Or they had some technology they wanted to apply and they looked where to apply that. So as opposed to saying, where's the highest financial leverage in our company? The second one is to capture and integrate domain knowledge, right? And that's human domain knowledge. Remember that people in your company are already running these business processes very effectively. They know a lot about it. You don't want to start from scratch with an AI. The third one is, and we'll get into this in a minute, is to be as scientifically rigorous as possible, not to over-apply that. I mean, corporations are not research institutions, so you can't be a pure academic, but you have to apply the scientific principles. The other one is apply best practices to data science engineering, not just someone's doing it and like you're going to do it, but you're actually aware of people are trained on those best practices. The fifth one, focus on change management and buy-in as much as technology. That's actually one of the, I think, biggest reasons these projects fail, that people didn't get adequate buy-in from the business stakeholders about it, and didn't focus on how the business process would change, and that led to the immune reaction, if you will, and for the non-success of that project. The last one, continually measure real-world impact and continuously improve. Again, no one's going to argue that you shouldn't measure the impact, but that's a really hard thing to do. And people say, yeah, we're going to measure the impact. It's usually an afterthought, or it's not rigorous, and you haven't, when I say measure, you haven't gotten finance and the business unit on the same page with you. So your measurement doesn't hold much water. To really do measurement, it takes sometimes as much development and effort as doing the actual project. And that's a really key success factor. So to kind of double click on the be as scientifically rigorous as possible. So this is one visualization of the scientific method. I'm sure from high school we've all seen this, right? It starts with an observation or a question. For example, maybe how does pre-cruise spending relate to on-cruise spending? And the next step is you research that topic area. You read all the relevant literature for what's out there and get familiar with it. Then you form some kind of hypothesis, maybe like pre-cruise spend as a driver of on-cruise spending, that has no relation to it or diminishes on-cruise spending. But form a hypothesis. Then you test with some kind of experiment, or you actually design an experiment that will prove or disprove your hypothesis, and that really requires thinking about what's really observable. It involves thinking about causality as opposed to just correlations, and about which you can measure and not measure, and how you get the data that you really need. Then you analyze that data, of course, and you synthesize some useful general relations. You did see that this kind of spending seems to drive this other kind of spending. And then you report your conclusions in some way, and then maybe make another obvious question keep going around. And when you get to a certain level of capability or understanding that, you synthesize it into a more robust thing that you then call engineering. So for example, to build a building like this is only engineering because the science is already done and already set for a long time. So you can have science to build a building. But a lot of the stuff we're trying to build with AI still needs that scientific element to it. Now that scientific method looks very similar to the CRISP-DM methodology, which is the standard data science methodology. It's not exactly the same, but it's this understanding, data prep, modeling, evaluation, deployment, and then cycle. So it looks pretty similar, and the life cycle is pretty similar, but there's some real big differences in practice. Right? So for example, in science, it's kind of an uncompromising principle that you're totally open. There's no black boxes. You show exactly what you did. And you describe it in clear language, you document it, and you invite people to criticize it, and no one really believes what you did until it's been replicated. So you provide enough information, someone else goes and tries it themselves, and they can replicate it, it's taken as good. In enterprise data science or AI, people are generally pretty opaque about it. There's not a lot of documentation or peer review. There's ambiguity that's really right. People start kind of going with it before it's known that it's right. And so you don't have that kind of bedrock foundational building upon that you see in science. Also in science, the teams are generally very knowledgeable about all the relevant literature, and they employ the best practices in that area. And I mean, if you don't, you land that. But in corporations, you often see inconsistent and incomplete approaches taken. Teams are not usually well versed in the literature. They want to build something out and start building it. They don't go out and look at all the literature, how other people approach this problem, what's the known best techniques, and so forth. And the other one in science, there's a focus on measurement. It's a big part of how I measure this, and on purpose generated data. Meaning, you say, say, what data do I need? And then you figure out how to get that data. No one in science says, what data is lying around, find something to use it. Whereas in corporate AI, people mostly use the data that's already lying around. Right? So what data is there? And it's kind of encouraged by some of these impressions people have out there. They say things like, I know I'm sitting on a mountain of data, and there's so much value in there, and I can just find it. And I think that's a real wrong-headed approach. You should say, what data do I need? And then go ahead and get it. But sometimes to bootstrap yourself, you have to use the data that's just there to show the promise of value. But really, you want to get the data that you need. That's how you make real advances. The next, and those 6 key elements of success, I've only got time to talk about 2. So the second one is the capture and integrate domain knowledge. As I said before, people have been running these processes for a long time. We want to be able to use that. In fact, in a lot of cases, if you don't, you won't be successful. So it's important to be humble. It's important to go with the business, learn how the process works, and get them to understand a little bit about how data science works, and work together. So I'll give one example of what I mean by incorporating using domain knowledge. Here's an example of how you might do either predictive maintenance or performance management on a turbine or an aircraft engine, which kind of have the same structure. So you have the engine you see at the bottom of the slide there, and you have the measured operational factors. That's the way you say the pilot is flapping, the throttle position, and all that kind of stuff. So the operational factors, you're taking the sensor data off the engine, and then the actual performance, whether it's performance while it's flying, whether it's maintenance issues, maintenance performance. You take those things you care about, the targets basically, and with those, you combine them all by some machine learning model, and you try to either predict failures or measure performance values and so forth. Now, the problem with this is you're ignoring the fact that people understand how the engine works already. There's engineers in the company that made that built it, and they understand the engineering and physics of it. And so you're kind of asking the machine learning model to relearn 300 years of fundamental physics from a pretty small sampling of the behavior of the system. And it turns out I tried to do this in my years at IBM, and it failed miserably. And then when I went to GE, GE actually made the equipment, we understood the engineering and so forth, and so you could incorporate domain knowledge. Here's how you incorporate domain knowledge in a case like this. You take measured operational factors, and you see in the bottom left of the slide there, these are the engineering equations that govern the operation of that aircraft engine there. And those measured operational factors, you'd say, what numbers, a given set of conditions, what should those sensor values be? What should the temperatures, the pressures, the flow rates, what should all those be theoretically given the engineering model? And then you take a delta between that and the actual sensor values. And that's what you feed into the machine learning model, right? So now you're not just feeding these random signals into the ML model, you're putting in a signal that is the discrepancy between the theoretical value and the actual value. And when you do that, with performance data in there, when you do that, you get much, much more accurate models because you're starting with the physics and engineering and using machine learning to cover the discrepancy between that and the real world. And you can look at this if you want to from a data science language. You could call this super advanced feature engineering. Right? So what you're really doing are creating better features than the raw sensor variables from these engineering equations. And so that's the 2 I mentioned. 2 of the secrets that I'll mention. We have Merck here, who's on our team, just to give an example. He actually started his career, correct me if I have anything wrong there, he started his career as an engineer, marine engineer. So understanding the equipment on the ship very, very deeply and working on that. And then he started building up his skills in data science and machine learning. And now he's leading our group that's going to be working in those areas. So that's I think it's important not to just work with the business, but that people on your team understand more details about the actual systems that you're working on. So that's the 2 I covered, the 2 critical success factors. That's all we have time for today. Happy to talk about the other 4. We'll do it over in the future talk.
Right over there, Senator.
So, question for you, when you talk about understanding this domain knowledge, my question for you is, how much do you think is the role of data scientists to develop, right, those business expertise, like which generally they're not trained with, they want to that high cost. This
Right, so the question basically, if understood, kind of is domain knowledge is so important. To what extent do you have your data scientists get really deep in the domain? Because, for example, they're not trained in supply chain or logistics or this. So to what level do they need depth in that understanding? And I would say, first of all, to as great an extent possible, it depends on how complex the business process is. I'll give an example. For example, when we're working in revenue management, we actually have some of our data scientists go and work part-time doing that job. You know, so they were like a junior level for this other job, just to, and for like many months, to get a feel for it. So it is important not to just have a rough view, the deeper view, the better, because then you can actually have very meaningful and not just meaningful, but trust conversations with the business. Because a lot of the business, I'm sure you find this as well, some business are a little bit suspicious of the data scientists coming in. You know, because they're going to look at it. You need some trust, and when you can speak their language and understand some of the nuances, you get a lot more trust and be more successful. Now, not everybody on your team can do that, so it's at least important to have some leaders on the data science team that are pretty deep in it. They can kind of bring that back to the nerds sitting around the, just making models. You need it on the team, I think, pretty well. And the opposite of that, I've seen examples at other companies, not my current company, but where the data science team came in and were almost disdainful to the business function. They're like, you guys are, you don't know how powerful AI is. Just give me the data and the targets, and I'll and then business doesn't trust them. You're not going to get the change management right. The models aren't going to work well. So you need at least a little, but as much as possible, at least one or two members of that team that are doing that.
We have time for one more super quick question from Angela.
Hi, thank you so much for your discussion. So one of your slides talked about best practice for governance and in your organization. So can you describe a little bit of what you're doing in that front?
For governance specifically?
Yes.
Yeah, so on government, I mean, we manage the data governance, policy for the company. So we do some of the basic things, just like data retention and all that kind of stuff. And of course, there's a lot of governance now around the security side of things, and especially with generative AI, with legal and security, are nervous about a lot of things. And in many cases, it's over nervous. So we're putting governance in there in terms of who's allowed to use certain kinds of models with the data that we have and complying with emerging regulations. So we have a governance team with a director that leads that team that manages all these areas. And then there's also governance, of course, around models being responsible and about so they're not biased in certain ways. And so we regulate monitor all that as well. But it's a team. It's a whole team around the department that focuses on this. And then there's training. They put out there's a mandatory training and data policy training that every